Section 1.5 is linear first order equations. At this point in our life, the only kind of equation we know how to solve is separable. Today we're going to learn a new kind. We're going to learn something called linear. So, a first order equation is linear if it can be written in the form dy dx plus p of x times y equals q of x. Where p of x and q of x, we'll make them continuous because that always makes things a lot easier. Now this, what does p of x mean? Function with respect to x, correct. This function with respect to x could just be a constant, could just be the number 5. And the same with this q of x. They won't always have x's in them. We would accept it if they just had constants. Okay? To solve a linear equation, you're going to compute something called rho. Rho is known as an integrating factor. Rho is going to be e to the integral of p of x dx. So you're going to compute that thing. E to the integral p of x dx. That's what rho is. And then you're going to take your equation, your original differential equation, and you're going to multiply everything by this new thing, rho. So you're going to have rho times dy dx plus rho times p of x y equals q of x times rho.
Wait, p is rho and p is... No, rho is a p.
Rho looks like p. Rho is the Greek letter p.
Okay.
So I've tried to... Rho looks a lot like p, so I've tried to distinguish by writing this one looking like a little p and that one looking like a capital P.
All right.
Okay. If you've done everything correctly up to this point, the left-hand side should then factor in a very special way. The left-hand side will factor as the derivative of rho times y. If you've done it correctly. Which means your differential equation becomes the derivative of rho times y equals rho q of x. How does that help? Well, we'll leave that. We'll leave it. We won't write the letter rho when we actually do these in practice. We'll leave the e to the integral thing right in there. We'll see how that works in a minute. But how does this help? What can I do with this left-hand side to get rid of this derivative now?
Well, since rho is...
I can just integrate. Because what do integrals and derivatives do to each other? Integrate. In this rho here, this rho only had x's in it, didn't it? So this thing on the right-hand side is only going to have the letter x in it. So I can now integrate. And I'm going to get rho times y is the integral of rho q of x dx. And then finally I can get the y all by itself by dividing by that rho. So y is going to equal the integral of p of x times, or the integral of rho times q of x, and then we have to divide that by rho. It's a lot easier when you do it in practice.
No,
But that's the general idea.
but because rho has a x in it, you can't just pull that out here from the rho.
Correct. Rho is not a constant. Rho is a function that has x's in it. So you can't just say I'm going to pull that rho out and then reduce with that rho.
So you have to wait till after you take the integral?
Correct. You have to take the integral first and then divide by the rho.
Oh boy.
Oh boy. All right. Well, let's try one. Looks scary. Y prime minus 2y equals 3e to the 2x, and this one even has an initial condition, y is 0 is 0. Well, the first thing you need to do is you need to recognize that this equation is linear, not separable. How do you recognize that this equation is linear and not separable? Well, we do have a y prime and a y on one side and an x on the other.
But even if you couldn't really separate the y from the x, because if you try to put it to one side and try to back things out, you have the x plus the y.
Correct. Remember, this y prime here is really a dy dx. So if I were to add this 2y over and try to separate my variables, I can't. So you got to recognize that here's our dy dx minus some function times y equals some function that only has x in it. So it fits into our linear pattern. Our linear pattern is dy dx plus q of xy, q of x in the, or p of xy, p of x in this case is just a number -2, equals some function q of x over here. All right, so we compute the integrating factor. We compute rho. Rho is e to the integral of p of x dx. So that's going to be e to the integral. What's p of x this time?
2.
Not 2, but close to 2.
-2.
-2, because the original formula had a plus there. So that's -2 dx. So that's e to the, what's the integral of -2? -2x. So there's our integrating factor. E to the -2x. I'm going to take that e to the -2x and I'm going to multiply it through the whole equation. So I'm going to have e to the -2x y prime minus 2e to the -2x y equals 3e to the 2x times e to the -2x. When I do that, some really nice stuff happens. What's the really nice thing that happens on the right-hand side? They cancel out, you get 3. On the left-hand side, if we've done it correctly, the left-hand side should be the derivative of our rho, which was e to the -2x, times y. It should always be rho times y. Is that correct? If I take the derivative of that, do I get the left-hand side up above? Well, I've got multiplication there, so in order to take the derivative, I need to use the product rule. So to use the product rule, I leave the first one alone. That's my e to the -2x. I take the derivative of the second one. The derivative of y is y prime. Then I leave the second one alone. There's the second one left alone right there. I take the derivative of the first one. What's the derivative of e to the -2x? -2 e to the -2x. So it worked. I integrate both sides. When I integrate the left-hand side, simply gets rid of the derivative symbol. I integrate the right-hand side. 3x plus c. And then finally I get y all by itself. Y equals 3 e to the 2x plus c e to the 2x. Because what I did to get rid of that e to the negative 2x is I multiplied everything by e to the positive 2x.
Where did the 3x go? Or shouldn't it be an x?
Yeah,
3x,
plus c.
3x, e to the 3x. The integral of 3 is 3x, correct. I think I said it and I wrote it wrong. Very last step, plug the initial condition in. 0 equals 0 plus c. C is 0. Final answer, y equals 3x, e to the 2x.
Multiply e to the 2x or e to the negative 2x?
I multiplied by e to the positive 2x because e to the positive 2x times e to the negative 2x, I would add my exponents. They would add up to 0, which would be 1. Other questions? All right, let's try another one. How about y prime equals 1 minus y cosine x. And our initial condition, y at pi equals 2. All right, this is a very interesting problem, in my opinion. What's very interesting about this problem? It's got trig in it. I always like problems with trig in it. That's true. That's not what I was thinking of, though, but that's a good point.
First thing that popped up in my head was
The warning flash, avoid trig. Now the trig's
George.
not so interesting here. Well, it is, but that's not what I was thinking. It is separable, isn't it?
Yeah.
Because I could divide by the 1 minus y and multiply by dx, and it is separable.
Why are we doing it this way?
Because it's also linear. So the reason I like this problem is this problem is interesting because it can be done different ways. And we're going to see that's quite common with differential equations. Quite often they fit more than one format. This one is separable, but it's also linear. So I'm going to pretend that I didn't recognize that it's separable, and I'm just going to do it as a linear equation. So as a linear equation, I would write y prime equals cosine x minus y cosine x. I distribute the cosine x. That's correct.
Y cosine x on the other side.
So y prime plus, I'm going to write it as cosine x times y equals cosine x. That's a plus. So now I notice I have it in my linear format because I have y prime plus p of x times y equals q of x. So this one is also linear. I compute my integrating factor. My integrating factor is rho equals e to the integral cosine x dx, which is e to the sine x. I multiply my whole equation by e to the sine x. That's e to the sine x y prime plus e to the sine x times cosine x y equals e to the sine x times cosine x. If I've done everything correctly, my left-hand side should be the derivative of what? The e to the sine x times y. And my right-hand side, I guess I'm not going to do anything with that yet. E to the sine x times cosine x. And again, I think it's a good point, a good idea at this point to check. I take the derivative of the left-hand side. I leave the first one alone. The derivative of the second, that's y prime. Plus, I leave the second one alone. There's my y. I take the derivative of e to the sine x. I get e to the sine x times cosine x. So it's kind of nice that it's got kind of a little built-in check right there, right in the middle. Take this derivative. If you did everything right, it should work. If it didn't, you made a mistake somewhere. That's right. I mean, those are the only options. Either it worked or you made a mistake. No in between there. We integrate e to the sine x times y equals the integral of e to the sine x times cosine x dx. Which is, what's the integral of e to the sine x times cosine x? It's e to the sine x. It's a u substitution problem. U is sine, the derivative of sine is cosine. So this is just the integral of e to the u. A straight u substitution problem. E to the sine x plus c. Divide by e to the sine x. I have y equals 1 plus c over e to the sine x. Yeah, remember you got to divide everything by e to the sine x because it's not a constant. Finally, plug in my initial condition. 2 equals 1 plus c over, I plug pi in. What's sine of pi? Sine of pi is 0. You were telling me the final answer because e to the 0 is then 1, which tells me c is 1. Alright, so the solution to that differential equation with that initial condition is 1 plus 1 over e to the sine x. Questions on those?
Why didn't you just divide by cosine x?
Because I wanted to practice solving linear equations. But you're right, if this problem were on a quiz or was on a test, which way would you solve it? Whichever way you think is easier. If you think separable is easier, solve it as a separable. If you think linear is easier, solve it as a linear. If you think linear is easier, you should check yourself. I think separable is definitely easier. Max? From here to there? To go from here to there, it's always the step you're going to take. Once you've multiplied by your row, I multiplied everything by my row, that gave me that third line. Your next step is always going to be the left-hand side should be the derivative of rho times y. That's always the step there. And then you just do a quick product rule to check that it's right and you haven't made a mistake anywhere. Okay?